Hey everyone, welcome back. In this Math 20-1 video, we are doing 20 worked examples from RF1, RF3, and RF4. That means factoring polynomials, reading quadratic functions in standard, vertex and factored form, finding zeros, vertex, axis of symmetry, domain and range, and using quadratics in applications. Please like the video and subscribe to the channel, and let's work slowly. Example 1. Factor 6x squared plus 15x. The greatest common factor is 3x. Divide each term by 3x. 6x squared divided by 3x is 2x, and 15x divided by 3x is 5. So the answer is 3x times open bracket 2x plus 5 close bracket. Example 2. Factor 4x cubed minus 20x squared plus 24x. First factor out the greatest common factor, 4x. We get 4x times open bracket x squared minus 5x plus 6 close bracket. Then factor the trinomial. Two numbers that multiply to 6 and add to -5 are -2 and -3. The final answer is for x times x minus 2 times x minus 3. Example 3. Factor x squared plus 11x plus 24. We need two numbers that multiply to 24 and add to 11. 3 and 8 work. So the factorization is x plus 3 times x plus 8. Example 4. Factor x squared minus 2x minus 35. We need two numbers that multiply to -35 and add to -2. -7 and +5 work. So x squared minus 2x minus 35 equals x minus 7 times x plus 5. Example 5. Factor 3x squared plus 13x plus 4 using decomposition. Multiply a times c. 3 times 4 is 12. The numbers 12 and 1 multiply to 12. And add to 13. Split the middle term into 12x plus x. Then group 3x times x plus 4 plus 1 times x plus 4. The factors are 3x plus 1 and x plus 4. Example 6. Factor 6x squared minus x minus 2. Multiply a times c. 6 times -2 is -12. We need numbers that multiply to -12 and add to -1. -4 and 3 work. Split the middle term, group, and the answer is 2x plus 1 times 3x minus 2. Example 7. Factor x squared minus 49. This is a difference of squares. X squared minus 7 squared factors as x minus 7 times x plus 7. Example 8. Factor x squared minus 14x plus 49. This is a perfect square trinomial, because 49 is 7 squared, and the middle term is -2 times x times 7. The answer is x minus 7 squared. Example 9. Find the zeros of y equals x squared minus 9x plus 20. Factor the trinomial. Two numbers that multiply to 20 and add to -9 are -4 and -5. So y equals x minus 4 times x minus 5. Set each factor equal to 0. The zeros are x equals 4 and x equals 5. Example 10. For y equals x squared minus 8x plus 12, find the vertex from standard form. The axis of symmetry is x equals -b over 2a. Here a is 1 and b is -8. So x equals 4. Substitute 4 into the function. 16 minus 32 plus 12 equals -4. The vertex is 4, -4. Example 11. Read the key features of y equals -2 times x minus 3 squared plus 5. This is vertex form. The vertex is 3, 5. Since it is -2, the graph opens down and has a vertical stretch by factor 2. The axis of symmetry is x equals 3. Example 12. For y equals 1/2 times x plus 4 squared minus 6, state the transformations. The graph moves left 4 and down 6. Because it is 1/2, it opens up and is vertically compressed by a factor of 1/2. The vertex is -4, -6. Example 13. For y equals x minus 1 times x minus 7, find the zeros, axis, and vertex. The zeros are 1 and 7. The axis is their average 4. Substitute x equals 4. Y equals 3 times -3, which is -9. The vertex is 4, -9. Example 14. For y equals -x plus 2 times x minus 6, find the zeros and opening direction. The zeros are -2 and 6. The coefficient is -1, so the parabola opens down. The axis is the average of -2 and 6, which is 2. Example 15. Convert y equals x squared plus 6x plus 1 into vertex form by completing the square. Half of 6 is 3, and 3 squared is 9. Write y equals x squared plus 6x plus 9 minus 9 plus 1. The trinomial becomes x plus 3 squared, and the constants combine to -8. So y equals x plus 3 squared minus 8. Example 16. Convert y equals 2x squared minus 8x plus 5 into vertex form. First factor 2 from the x terms. Y equals 2 times open bracket x squared minus 4x close bracket plus 5. Half of -4 is -2, and -2 squared is 4. Add and subtract 4 inside the bracket. The result is y equals 2 times x minus 2 squared minus 3. The vertex is 2, -3. Example 17. State the domain and range of y equals 3 times x minus 5 squared plus 2. The domain of any quadratic is all real numbers. The vertex is 5, 2, and the graph opens up. Therefore, the range is y greater than or equal to 2. Example 18. State the domain and range of y equals -4 times x plus 1 squared minus 3. The domain is all real numbers. The vertex is -1, -3, and the graph opens down. Therefore, the range is y less than or equal to -3. Example 19. A quadratic has zeros at -3 and 5 and passes through 0, 15. Start with factored form. Y equals a times x plus 3 times x minus 5. Use the point 0, 15. 15 equals a times 3 times -5, so 15 equals -15a. Therefore, a equals -1. The equation is y equals -x plus 3 times x minus 5. Example 20. A ball's height is h equals -5t squared plus 30t plus 2. Find the maximum height. The time of maximum height is -v over 2a. That is -30 over 2 times -5, so t equals 3. Substitute t equals 3. H equals -5 times 9 plus 90 plus 2, which is 57. The maximum height is 57 meters. Great work! In RF1, RF3, and RF4, your routine is factor carefully, identify the form. Use standard form for y-intercept and axis. Use vertex form for transformations and range. Use factored form for zeros, and connect every algebraic answer back to the graph. Like the video and subscribe for more Math 20-1 worked examples.